Hi, I'm Danielle Peterson, and today for CPD On Demand, I will be chatting with Johan van Wyk, the director of the Southern African Ready Mix Association, or SARMA, and we're going to be talking about hardened concrete testing. So thank you for joining us, Johan.
By all means, thank you for the invite.
Now, can you start off by giving us an overview of hardened concrete testing and what it is?
Danielle, hardened concrete testing is what we do to accept the concrete after it has been cast. Now, there are two types of acceptance control. The one is the slump test, which we have done previously, and that is to accept the concrete for it to be cast. Then once the concrete is in the structure, then obviously we need to know that that concrete in the structure has attained the correct strengths and that it is up to specification. And that is where hardened concrete testing comes from.
Okay, so what is the process of conducting hardened concrete testings? What kind of information are you looking for?
We're basically looking to know what the strength of the concrete is that is in the structure. Once it is set, probably on 7 or 28 days, we can test that. The normal specification for concrete is to determine the strength on 28 days. And it is also specified and designed for concrete to reach a certain strength on 28 days. We can design it for any strength on any day, but 28 days is the norm. So we need to know that the concrete has been cast and manufactured according to a specific specification. And that specification is determined by the design that the engineer designed for the structure.
And I see you've got some examples here for us, so maybe just explain the difference and where each aspect fits in.
Yes, these are the main tests that you see in front of me here. When it comes to hardened concrete testing, we do normally cube tests, and these cube tests are the compression tests that we do to determine the strength of the concrete. This is from the concrete that we sample on site, and if we do not have a cube test, or if the test results are low, then we move on to core testing, which is the next two that you see here. Now this is concrete that is removed from the actual structure. Okay. So core testing, when you've got low or no results, and cube testing is the primary hardened concrete test that we do.
Okay, so when you're looking at conducting a cube test, what is the process that you will follow?
Well, Danielle, it's easy to say that the most important part would be, but every single part of hardened concrete testing, similar to the fresh concrete testing and the slump test, but every single part of this test is crucial and is important. The reason why this is important, and before I go on to what the process is, should any part of the test fail, any part of the test not be done according to the specification, there might be a difference in the result. And if we cannot determine what exactly the magnitude of that difference is, then we cannot accept that result because we don't know how far out that result is. Also, if it is not done exactly the same as all of the other tests that we do according to the specification, then we cannot compare any of these results. So it's important that every single facet of any concrete testing is done exactly according to the specification. Any deviation will give you a difference in result, not necessarily a low result, but a difference in result. And if we can't determine what that difference is, we cannot accept that result. So on to the process. Firstly, you need to sample the concrete correctly. Sampling happens from a ready mix truck or out of a laboratory. If you're doing trial mixes, mostly on site, it's going to happen from the back of a ready mix truck. Sampling is important because you need to test the concrete that goes into the structure. So you need to have a representative sample. That's the most important, that's the key word when it comes to sampling, is representative sample. Then we move on to making actual cubes. There we've got preparation of the cube molds. You will then cast concrete into those cube molds. From those cube molds, they're removed after 24 hours. After 24 hours, they are cured underwater at a specific temperature, and then after curing they get removed on the day of testing. You will then test in a cube crushing machine, test 3 cubes to give you 1 result. Once you've got those results, you can compare them to the specification and you can draw some conclusions from what do those results mean in the structure.
Okay, Johan, you've got this great model here for us. Can you demonstrate, how the sampling would take place?
Danielle, sampling is incredibly important when it comes to testing, and as I've said, it's important to test a representative sample. So if you take a look at a ready-mix truck, first and foremost, when the truck arrives on site, remember that testing has to happen within half an hour from the truck arriving on site. Not half an hour from the start of discharge, half an hour from the truck arriving on site. This is according to the SA National Standard 878 for ready-mix. Then the next thing is the truck has to spin for 5 minutes. We do that because the truck drum turns very slowly while they're on their way to the site. Because it turns slow, the concrete starts to segregate inside the drum. There's a certain amount of segregation, so you need to spin the truck for 5 minutes or at least 100 revolutions. That lets everything mix through and homogenize the mix in the drum. Then the next thing is you need to discharge 15% from the drum. We don't test the first 15% or the last 15% of the concrete in the drum. So you're going to discharge 15% from the drum after that 5 minutes of mixing, and after then, and the truck drivers know exactly when 15% is out. They're very good, so you can trust the truck driver to tell you when there's 15% that has been discharged. From there, if you look at the chute here, the next order of business is not to put a wheelbarrow underneath the chute and simply fill it up. You need to take samples throughout the middle 70% of the drum. And you need to take those samples from a moving stream. That means as the concrete is coming down the chute, you would take a scoop or you'll take a spade and you will take continuous samples from that, filling up a wheelbarrow to get the representative sample. And you have to do that through the middle 70% of the drum. So the key points is spin the truck for 5 minutes. Test within the first half an hour from the truck arriving on site. Then you test from the middle 70% of the drum and you take continuous samples throughout that middle 70% from a moving stream of concrete to constitute a full sample. Well, Danielle, this what you see here is everything that you need to make cubes successfully. And if I can go through it, you see the vibrating table at the bottom, cube molds right here at the top. We've got a scoop, we've got a steel ruler, there is a trowel, and then of course the ever-present mold release oil. And this is everything that you would need to make successful cubes.
Okay, and I see you've got a variety of different molds here. Can you tell me what that's for?
Yes, as it is in the standards, you can use different types of molds, and they make provision for the 100 millimeter cubes, which is the two that you see right there, or the 150 millimeter cube that you see at the top here. As a matter of fact, we are going to go on to start testing cylinders as well when we move to the new codes. But just to iterate the differences, this is a PVC or a plastic mold, which is usable and works very well. Then you've got the steel mold at the back, which is probably the limousine. This is what gives you the best results. It is sturdy, but unfortunately it's made of steel. You know what happens to steel on a construction site. And then the 150 millimeter cube at the top. And the main difference between these three would be the manner in which you make the cube and how you fill the cube. For a 150 millimeter cube, you fill it in 3 layers, and each layer is then compacted, whereas for the 100 millimeter cubes, you're going to fill them in 2 layers, and each of those layers is compacted. And then the extraction as well, the 2 steel molds, you loosen the bolts, you pull apart the top part of the mold, the sides, and then that is how the cube is released. Whereas with the plastic mold, there's actually a hole in the bottom, and you put air pressure at the bottom, and that pushes the cube out to the top. I think something very important to realize about the apparatus that you see here is that it's always important to keep on checking your apparatus. Because this is a PVC mold, I suggest that every so often you measure the cubes, measure all of them, the PVC mold probably more so. So the measurement that we take is we would take this PVC mold or then the steel molds, measure across from the one corner to the other corner, compare that measurement over to the other two corners and compare those two measurements. Those two measurements needs to be within 0.5 millimeters. That tells you that your cube is still square. Apart from that, we also measure the inside edges on all four of the corners and then also the depth of the mold. And that check is important so that you make an accurate cube. You need to have the cube as accurate as possible to make the best possible cube. And the most important thing to remember is we do these cubes for the strength testing specifically to determine what the strength of the concrete is. So we have to be testing a representative sample, and then that representative sample needs to be the strongest possible cube that we can make. And the most important thing about that is to get the air out. We need to get the air out of the cube, hence the vibrating table at the bottom. Get the air out. Every 1% of air that you keep in your cube will lose 5 to 6% of the strength.
Wow.
So get the air out when you make the cubes.
Okay. Now, Johan, do you just make one cube? Do you make cubes of varying sizes? How does the process go?
As a matter of fact, the cubes that you make needs to be as close to each other, exactly the same. So my suggestion is that if you are going to use steel molds, you're going to have to use steel molds for the whole test. And if I say the whole test, you don't only make one cube when you test a batch of concrete. You've got to make at least 9 cubes because we use 3 cubes to be crushed to constitute one result. Normally, we only test on a 7-day and on 28 days. That's when we test the cube. So we will test 3 on 7 and 3 on 28. Each of those 3 would give you one test. Now, the reason why I say another 3 cubes is sometimes some things happen, and we know that happens, that maybe the test is not accurate, maybe it's tested on the wrong day, but that we've got those 3 cubes spare so that we can test them as well. Sometimes if we don't get strength on 28 days, we choose to do another test on 36 or 56 days, and then we can choose to test those 3 cubes afterwards. So, if I may, can I just go through how you prepare a cube? The preparation to do a concrete cube test starts well before the concrete actually gets to the laboratory or when you start making cubes. It's important these cubes need to be correctly assembled. Now, if you're going to take a look at this one that you see here, you can see that it's 2 halves of a cube that is being put together. And you can see where they were put together, this actual cube, and I specifically took out this one so you can see that is not well aligned. This cube mold would not give you a square cube. So that's the first thing to check. I think the easiest way is to remember that the 2 halves of a cube mold mate for life. They're like emperor penguins, so they stick together. And to stamp these cubes over the sides, you can see there's a little number there to know that these 2 halves stick together forever. So then what you do is, after the mold has been cleaned, you would assemble it correctly and then paint it with a typical mold release oil. After that, you'll take the cube will be inverted while you're waiting for the concrete. Cube will be inverted for the mold release oil to drain out. Too much mold release oil is going to change the friction coefficient on your compression machine. And you don't want that to happen because your cube can test lower. So you'll invert the cube. Once the concrete comes to the laboratory and you're ready to make the cubes, you would turn the cube the right way around. On the 100 millimeter cube, like I said, it's filled in 2 layers. Each layer is vibrated to get the air out. And on the 150 millimeter cube, you'll use 3 layers and vibrate all of that out. And very important, once you have done that, the cubes have to be stored in their molds for 24 hours, covered and protected out of the sun, not too hot, not too cold, to gain strength in the beginning. They're very fragile in the beginning. If you crack them then, your test is going to be lower. So that's the way that you're going to make the cubes, and then very important, you have to mark them, because we need to know where the concrete in the structure is, when it needs to be tested, when it was cast, and that is marked on the cube, so that we've got traceability from manufacturing all the way through to the test.
Okay.
So as previously stated, once the cubes have been molded, after 24 hours, when you take them out of the actual cube molds, those cubes have got to go into a curing bath. Now that curing bath needs to have water between 22 and 25 degrees centigrade, measured twice a day and checked, and it's got to be constant. You cannot put off the curing bath in the evenings. The water cannot vary in temperature, and you've got to keep it at that. Then after the 7 or 28 days, the cube is tested. Now you can see on this cube, clearly it is marked. We know exactly where it went into the structure. At the top it says column 3E, there's a date on it. This is cube number 1 of 3. So this gives you the traceability of the cube itself. And on 7 or then 28 days, when you're going to test this cube, you would come to a testing rig similar to this one. The cubes get removed from the water. You put them down so that they drip dry and that they are wet but not shiny. You need to let the water drip off. You can even dry them off with a cloth. Then the next thing to do is, again, we're going to check the measurements of the cube. The cube measurements cannot be out more than 1 millimeter in any direction. The easiest probably way is to use a go-no-go gauge. A no-go gauge is basically just a piece of steel that fits over the sides of the cube, and you check that all of the measurements are in specification. So after that, it will come to the cube crushing machine. First thing to check on a cube crushing machine, it has to be calibrated every 6 months by an authorized and accredited calibration authority. So then it goes into the cube machine. The cube always goes into the machine with the molded edges that makes contact with the platens. The finished edge, which is at the top and probably the one that is usually marked, is the one that faces forward. We do that because you can clearly see from this one that it is not a flat surface, and you cannot test on something that is not a flat surface. Also, in the cube molding machine, you would see these location pins. Those location pins are essential for the cube to go into the center of the machine. We will look at it later on at what happens if it's not in the center of the machine. The cube gets pushed back against the location pins. It is in the center of the machine, and after that, you then start the machine. The machine puts a force, a load onto that cube, and then when it comes out, we take that force, we divided it by the area. The area on this one would be 100 by 100 millimeters, and that gives you the MPa, or the pressure, and that is the compressive strength of the concrete.
Johan, once you've crushed the cube, what are you looking for? What can you expect?
Well, Danielle, very important is to observe the cube after you've crushed it. That is irrelevant of the actual result that you're getting. Remember, you're going to crush 3 cubes. We're going to take the average of those 3. The first thing about that is that if any one of those strengths of those 3 cubes is further than 15% from the average of the 3 cubes, that result needs to be discarded. There's a problem with that cube, and you can't include that. So that's the one thing that you're going to be looking for. The next thing is we have to observe the carcass of the cube, as we call it. So if you do an investigation on a laboratory, for instance, you would look at the carcasses of the cubes that's already tested, and that gives you a lot of information. The 2 cubes that you see in front of you here, the 100 millimeter cube on the right hand side, 150 on the left hand side, shows you the 2 most common failure modes that we see. The one on the right hand side, you see the hourglass figure, is what we want to see when a cube has been crushed. This cube has actually failed in compression. And remember that compression is what it is that we're testing. So this cube fails in compression, and you see that typical hourglass figure. On cubes that are not as strong as maybe this one, you'll only see cracks on the side, but all of those cracks are going to be vertical. There's no horizontal crack on a cube that has failed correctly. So that brings us to the second cube, and on this cube you can clearly see that there's a horizontal crack that runs across the cube at the back. This cube was tested incorrectly, and this is a tensile crack. We know that concrete is not as strong in tension as what it is in compression. So this tensile crack shows you that this cube has failed in tension, which means you haven't tested the compression correctly. And this means that if you see a carcass like this, the cube has failed incorrectly, and this result cannot be accepted.
And when something like that happens, would you redo the test?
As a matter of fact, you wouldn't be able to redo this test because you haven't got more of that concrete. But those 3 cubes that you've made extra,
Yes.
you can now use those 3 cubes and test them correctly. And if you then test them correctly, and if they are available, you can accept that test.
Okay.
What you have to investigate is why you've got a tensile crack here. It might be that the cube wasn't square, which means you've got to measure those other 3 cubes that you are going to be testing. Or it means that the cube wasn't square in the mold. And if the cube wasn't square in the mold, you've got to check the location pins and check that all of that is correct. Or it means that the 2 platens were not parallel. If the 2 platens weren't parallel, that can also give you this result. So I would say, depending on why you get that tensile crack, you can then retest. The most common way when we see this to move forward is to drill an actual core from the structure and then test those cores.
Okay, Johan, now you've demonstrated for us the process that needs to be followed in terms of creating the cubes and crushing them. What do we do now in terms of interpreting the results?
Danielle, you're going to take any of these results, and I'm going to reiterate again. Remember that crushing 3 cubes on a specific day will give you 1 result. Any one of those results, if it is further than 15% out from the average of the 3 results, that result would be discarded. You would recalculate with the remaining results. So the results that you're then going to get, you're going to compare those results with the not only the standard, but also with the specification as from the engineer. And then we evaluate those results according to the specifications to see that the concrete in the structure has actually passed the specification. Not only that, these results are also obtained for process control testing. That also shows us how well a ready-mix plant is performing. And we do standard deviations on that, a full statistical analysis to determine that the mix designs and the concrete plant is performing as we need it to perform.
Okay, and you mentioned if one of them is out by more than 15%, I think you said.
That's right.
It's discarded. Could there be an instance where you get 3 very different results from your 3 cubes?
Yes, it's very possible. And there are so many reasons why this can happen. The important thing is to, when you get the results, not only to look at them blankly, but to interpret the results and read something from the results and then learn from the results. Find out why that has happened, because that's going to give you clues for all of the rest of the results. But yes, you can get very different results, and it's important to then investigate why. And you're going to have to take that forward so that it doesn't happen in the future again.
And what do you do if you get the results and they don't comply with the standards or the specifications?
Well, the first result that you're going to get that is not going or might not comply is the cube result. Once you get the cube result and it does not comply with the specification, we move on according to the specifications again. There are certain steps that needs to be followed for acceptance. The first thing is that the engineer can choose to use the results that the ready-mix company supply. And if he trusts that, and remember that a lot of the ready-mix companies do have SARMA accredited laboratories that can be trusted and that are checked. So you can choose to accept those results to accept the concrete in the structure.
Okay.
Should you not choose to accept those results and you deem the cube results to have failed, then we move on to core testing. Now, core testing is exactly as stringent as what cube testing is. And that moves from extraction, where an engineer would show the places where the cores need to be drilled. Again, 3 cores are drilled. Those cores are put underwater. After that, they need to be cut. They need to be capped. You can see the capping on top here, on top of this core. This one has just been extracted. And then after that, it is cut so you get the right aspect ratio. It is the same thing. It's a science in itself. And I think it might be for later discussion. But then we move on to core testing. Once you get the core testing, then you need to interpret those results. And remember that core testing results is interpreted differently from cube results.
Okay.
And also, as soon as you've moved on to core testing, then you can't bring back the cube tests. Once the cube test has failed, deemed to have failed, and you move on to core tests, then the cube tests become null and void.
Okay.
Then the test that you fight with then is the actual core test. And the interpretation thereof, just to quickly go over that, is that core tests need to perform at 80% of the specified strength. That is the average that I'm talking about, needs to comply to 80% of the specified strength, and no single core can be under 70% of the specified strength. Then that concrete is deemed to have passed. So remember that a core test does not have to stand up to all of the scrutiny that we would normally put the cube tests through.
And what happens if the core test fails?
If the core test fails, then we have to go into full-scale load testing, where we actually take the structure and we put, the easiest way is obviously to use cement bags, but we put pallets of cement bags. When it comes to a bridge, we'll take full cement tankers or ready-mix trucks that we know how much they weigh. They get driven over that. We determine deflections to see if the structure itself can hold up to the loads. We might even do a redesign, but all of this is in the specifications and taken up there and has to be followed. You cannot just break down the structure unilaterally and then claim back from either the contractor or the ready-mix company. There's a process to be followed, and that process follows from cubes to cores, from cores to load testing, from load testing, remedial action. After remedial action, if we cannot do that, only then does the structure get broken down.
Okay. And when you're testing the core, does it undergo the same crushing test as the cube, or is it a different test?
It's exactly the same test in essence. The only one is that you've got a square, you've got a cube, which is square obviously, and you've got also the core, which we try to get the aspect ratio. Aspect ratio is the diameter of the core and then the height of the core. We try to get that as close as possible to each other. But from there, putting it in the machine, it needs to be square, it needs to be parallel. All of that is exactly the same. You put it into exactly the same machine, you put it in the center of the machine, and you also apply the load exactly the same. Then you take the load, the force exerted, divide that by the top area of the core, and then similarly, you get the same compressive strength.
Okay. And you mentioned laboratories a bit earlier. How do you go about selecting the right laboratory to do the testing and making sure that it's reputable?
I think generally it is accepted that so-called SARMA accredited laboratories is what needs to be accepted. I'd just like to say that rather than looking at a SARMA accredited laboratory, each person, before selecting a laboratory, needs to go onto the SARMA's website and needs to go look at the tests that are accredited in specific laboratories.
Okay.
Remember that a laboratory can be SARMA's accredited, but not be accredited for specific tests.
Okay.
So if you are going to specify a laboratory or use a laboratory that is, for instance, going to do cube testing, go onto the SARMA's website. Go look at their accreditation schedule, because that is updated very quickly and it's all up there, and that will tell you whether they are accredited for cube testing. Please do go further. If you're going to do cores, they need to be accredited for the extraction, the capping. They need to be accredited for sampling. All of those are different tests according to the SA national standards, and they need to be accredited for each of those. Also important is that a lot of the times the contractor or the engineer or the ready mix company or any of those would actually make the cubes themselves and only take them to the laboratory for testing. So also differentiate between that.
Okay.
If you're not SARMA accredited for sampling and you do that, then there's a certain premium and a certain risk that does come with that. If you need the whole process to be SARMA accredited, check the laboratory that everything is SARMA accredited according to the SARMA's website.
And what are the dangers of using a laboratory that perhaps isn't accredited or maybe doesn't produce the best results?
It comes down to the engineer. And if I say the engineer, I mean the person that has got to accept the structure. That's normally the designer of the structure. Whether it be a floor or a high-rise building, somebody needs to accept and sign off on the strength of the concrete and the quality of that concrete. So the dangers would be that if you've got somebody which is not accredited, they might not take the responsibility for those tests. And people or laboratories and ready mix companies and testing facilities, any of those, get specifically accredited so that you've got traceability and you've got accurate testing. So that accreditation goes further than just being able to make a cube. It goes to if the people are competent, traceability of what it is that they're doing, that all of their machines are calibrated, all of their apparatus are calibrated. Something as small as a steel ruler that's not calibrated might throw out a result. So all comes back to traceability and comparability of the results amongst laboratories. Now please note that an engineer, or anybody for that matter, can specify any laboratory and any testing regime and choose to accept those results. So never is anybody saying that you're only allowed to use a SARMA accredited laboratory. SARMA accreditation is like SARMA accreditation. It's an external check that everything is up to a certain standard.
Okay, and the whole time we've been talking, you've stressed the importance of following the correct procedures, doing it right. Could you just summarize for us the key aspects to watch out for, what can affect or skew the results, and how you need to exactly follow the right process?
Well, first and foremost, I'm going to say it again, sampling. One of the most important things in sampling is to spin the truck for 5 minutes. Take a representative sample. You want to test the concrete that's in the structure, representative. Don't test something which is not representative of the concrete that is going to do the work in the structure. So that is obviously important. Take a representative sample. Then, when you start making the cubes, it's important that cubes are square and that cubes are vibrated to get all of the air out. In order to get the cube square, obviously you've got to take care when you make up the cubes themselves. Check them again, and then check the cubes. If you can just sort out the squareness of a cube, then you've gone very, very far. The next thing is the cube is tested on the flat sides of the cube and not the front side. You can clearly see that this is not a flat surface.
Yes.
If you were to test there, then you'll find that this cube will test lower. Then when it comes to interpretation of the results, it's also important to check that you interpret according to the standards and you compare like with like. Don't compare a non-representative sample with something that you need to have tested. And then finally, I have to say, anything that you deviate from in any of the tests, we've already said that it is going to make a difference. We also know that we don't know what the magnitude of that difference is. What's important to understand is that there's no test devised. If you do the test wrong, if you deviate from the code, every single test that you do, everything that you do will give a lower result than the concrete. There's very little that you can do to give a higher result. If you cheat, you get a lower result. And a lower result will make it seem that the concrete has failed, when in actual fact, the test has failed and not the concrete. To move on from cubes to cores is expensive. A cube costs 50 Rand a cube to test. A core is 1,500 Rand each.
That's a big difference.
So we might as well do the cubes right. It's 1 liter of concrete, and if we do it right, we can make informed decisions. And then we can accept the concrete. Rather do the test correctly so you know what's going on in the concrete. Don't let the test fail.
Okay, do you have any closing comments or anything that you want to leave the viewers with?
Yes, I would say that testing doesn't just happen. Whether it is acceptance control or process control, testing doesn't just happen. You have to plan to test and agree beforehand who's going to do the testing. And then the ready mix companies test for process control to check that their plants are running at a certain level. Those results are not necessarily there for the engineer or for submission. And because they only test 1 in every 50 cubic meters of concrete, your concrete might not even be tested if you only ordered 1 truck. So remember to plan to do testing, to specify testing, and to agree beforehand what is acceptable when it comes to the testing.
Well, Johan, that's fantastic. Thank you so much for your time and for sharing your knowledge with us today. This has been CPD On Demand.